All right, absolute value equations, day 2. On day 1, we were working with absolute value equations that look like this. The absolute value of 2x plus 4 equals 18. And what we did with those is we took and said, all right, absolute value can have a possibility of the inside being positive 18 or negative 18. And so we wrote out our equations like this. We said 2x plus 4 equals 18, or 2x plus 4 equals negative 18. All right, so then we solved each equation from there and we checked our solutions. Well, today we add something else to that. When are two absolute value expressions equal to one another? Well, there's two situations that arise. When you have two absolute value expressions that are equal to one another are when you have the same number inside the absolute value sign. So here I have 3 and 3 on the inside because the absolute value of 3 equals the absolute value of 3, or the absolute value of negative 3 equals the absolute value of negative 3. The second situation that we could see two absolute values having the same answer or being equal to one another is when the numbers on the inside are opposites. So I'd have the absolute value of 3 equals the absolute value of negative 3, or the absolute value of negative 3 equals positive 3. So we have two situations when absolute value expressions can be equal to one another. That the inside of the absolute value sign will give us the same result with the same sign, or the inside will give us opposite results, and then the absolute value then allows us to have answers that are equal to one another. So then, what does that mean? So how would you then solve a problem like this? All right, so as you're watching the video now is the time that you should be writing things down, following along with me. Feel free to pause the video. You can stop it at any time so you have time to write, and work with me right now. In a minute, I'm going to have you try a problem, and then we'll see the answer and we'll work again together. So 4x minus 5, the absolute value of 4x minus 5 equals the absolute value of 3x plus 5. Two situations. The inside would be the same. So I say 4x minus 5 has to be the same as 3x plus 5. First situation. We have a second one to solve, and we'll deal with that in a minute. So the first situation is the two would be the same value on the inside. So I will solve my equation. I'm going to do 3x, 4x minus 3x. That gives me x minus 5. And I have 5 left on the right side. Add 5 to both sides, and I say x equals 10. All right, so now we have a solution of 10. If we check that, I'm going to check that absolute value. So 4 times 10 is 40. 40 minus 5 gives me a absolute value of 35. And I want to know, does that equal, we'll check the other side. Now on the inside, we're looking to get either positive 35 or negative 35. So let's see what we get. 3 times 10 is 30. 30 plus 5 is 35. So I have the absolute value of 35. So here I have the same number on the inside. Both have the same absolute value. That means 10 is one of the solutions. Now, as we mentioned a minute ago, the insides could actually be opposite of one another. So I need to set up a second equation. So then I can say 4x minus 5. One will just stay as it is. And the other one becomes its opposite. So I say the opposite, and I must put it in parentheses. So then I will be turning each term on the inside of the absolute value into its opposite. Now I will solve my equation first by distributing my opposite signs. So on the right side of the equation, I have negative 3x minus 5. And I will just copy the left side of the equation, 4x minus 5. And now I'm back to solving the equation. So I'm going to take a couple of shortcuts on you here. 4x, and I will add 3x to both sides, so I get 7x. If I add 5 to both sides, I get 0 over on the right side. Divide by 7 on both sides, x equals 0. Now if I check that for my absolute value work, so the absolute value, 4 times 0 minus 5, 0 minus 5 is negative 5, equals 3 times 0 is 0. 0 plus 5 That is 5. So now if you look on the inside of our absolute values, we have opposite numbers. However, this is still considered a solution that works because both have the same absolute value. Therefore, we have 5 equals 5, and it means 0 is a solution. So we have two solutions here that work. X equals 10 or X equals 0. Now, I'd like to take a moment. Would you copy down this problem? This is actually problem 21 out of your textbook. I'd like for you to write this down, pause the video, try to work this problem, and then start the video again so you can see how the problem is worked. So please pause the video now. All right, you've paused the video and you've come back. Now we'll take a look at this problem together. All right, so we'll have both of them stay the same. 5x minus 7 equals 3x plus 11. Or we'll have one stay as it is, so one is going to keep its signs. The other one becomes its opposite. So let's solve the two equations. On the left side, I'm going to now combine my variables. 5x minus 3x is 2x. I will add 7 to both sides. They are like terms. 11 plus 7 is 18. Divide both sides by 2. I have a solution that says x equals 9. When I check that solution, 9 times 5, 45. 45 minus 7 is 38. So the left side of this has an absolute value of 38. The right side of the equation, 3 times 9 is 27. 27 plus 11 gives me an absolute value of 38. So I get the same absolute value there. That means 9 is the solution that works. All right, let's now try the other side. 5x minus 7 equals the opposite of 3x plus 11. So 5x minus 7 equals negative 3x minus 11. Combine the variables, 8x on the left side. Add 7 to both sides, so I get a negative 4 on the right. So x equals negative 4/8 or negative 1/2. So if I check that, I'm going to put negative 1/2 in, so I have a negative 5/2 minus 7. If I change 7 into halves, that's going to be minus 14/2. And when I subtract that, I get a negative 19/2. So now we'll see what we get on the other side of this equation. Substitute that in, I get a negative 3/2. Negative 3/2 plus, well, 11, if I change that into halves, is going to be 22/2. So negative 3 plus 22, that's going to give me 19. Now I do get the opposite answer I had over from before, but because I'm doing the absolute value of both, and both have the same absolute value, that means negative 1/2 is a correct solution. All right, so now let's take a look at problem 22. This is from page 99 in your book. I know you probably don't have your book with you. You're watching this at home. But would you please write this problem down, pause the video, and try to work this problem. All right. Thanks for giving that a shot. Let's see what we do here. 9y plus 1 equals 6y plus 4. 3y equals 5. Oh, my apologies. 3y equals 3. I should be subtracting there. So 9y minus 6y is 3y. 4 minus 1 is 3. Y equals 1. So on this one, on the absolute value, 9 times 1 is 9. 9 plus 1 is 10. 6 times 1, 6. 6 plus 4, that is 10. So I have absolute value of 10 equals absolute value of 10. Correct solution. All right. The other side, keep 9y plus 1. That is going to equal the opposite of 6y plus 4. So I have to do my opposite on the right side. So 6y minus 4 equals 9y plus 1. I have 15y. When I combine my y's, I combine the numbers. Negative 4 minus 1 is negative 5. So I get my negative in there. And that's going to be over 15. So that simplifies to negative 1/3. If I check negative 1/3, so I take negative 1/3 times 9, that's a negative 9/3 plus 1. That's like negative 3 plus 1, so then I have a negative 2. If I check it on the other side of the equation, negative 6/3 plus 4. Negative 6/3, that's the same as negative 2. Negative 2 plus 4, positive 2. So here I have two absolute values. Both have the same absolute value. That means negative 1/3 is a correct solution and 1 is a correct solution. All right, would you take a moment to copy down problem 23? Problem 23 is a situation now where actually you're going to see how we can run into problems that we only have one solution or a solution doesn't work. So if I start this one out and I'm going to say z plus 8 equals z minus 3. And I solve this problem, I'm going to subtract z from both sides, and I get 8 equals negative 3. Well, that is false. That means I'm not going to be able to get a situation here where I have the same number on the inside. So now let's check and see if we can get opposite numbers on the inside. So say we're going to write z plus 8 equals the opposite of z plus 3, or z minus 3. Sorry about that. Z plus 8 equals the opposite of z plus 3. Add z to both sides, 2z. Subtract 8 from both sides, negative 5. Divide by 2, negative 5 halves. So let's test it to make sure it works. So that now, this should then give us, hopefully, we'll have two opposite numbers on the inside. First absolute value, negative 5 halves plus 8. Well, 8 in the terms of halves is actually 16 halves, isn't it? So we'll write that down that way. The negative 5 plus 16 on my numerators gives me 11 halves for an absolute value of. Well, let's check and see what we get on the other side. Negative 5 halves, I'll put that in there. Negative 5 halves minus 3. Well, 3 is the same as 6 halves. So negative 5 minus 6, negative 11 halves. So once in a while we can run into something that has just one solution, especially if we get a false statement on when we're trying to find the absolute values are either the same or that they're different. But if I get something that's false, if this is a problem, then I'll have with just one solution. All right, thanks for watching. Hope you took some notes. Bring those into class with you, and then you'll be seeing your assignment when you get into class the next day. All right.